Our lesson for today will be looking at chemistry 1502. The topic for today will be dealing with alkanes, which is one of the most important homologous series that we have. Lesson 101, let us start. Let me actually rephrase my statement. It's the most basic homologous series. All the homologous series are important. So when we talk about alkanes, you should know that in this lesson series, we'll be looking at different types of homologous series. We will be dealing with organic molecules. When I'm talking about organic molecules, I'm talking about those molecules that consist of carbon inside. So you should know that the basic of organic chemistry is based on all those molecules that contains a carbon. Now we've looked at the basics of carbon when we're dealing with Lewis dot diagram. When we're dealing with resonance structures, we definitely know that carbon bonds 4 times. That is its valence electrons. It has 4 valence electrons. So when we talk about alkanes, the first thing that you should know is the general formula for alkanes. It's CnH2n plus 2. Write this down and then you'll know how to use this as we continue this lesson video. We have the first 10, but I'll be covering only the first 8 important prefixes or names that we have in all these homologous series that we have. You should know that the first compound is methane under alkanes. Methane is structural formula or Lewis diagram. It's CH3. This is the molecular formula. Then this is the structure of methane. If you can check during our group discussions or during our chemistry discussions or lessons, I would normally give names of these types of compounds. So now I'm teaching you these names like ethane, methane, ethanol. We'll just see how we can derive these names. The second one is ethane. Ethane, it consists of 2 carbons. It's actually C2H6. This is ethane. The next one is propane, which has 3 carbons. Then the molecular formula is C3. Then you can clearly count. We have 8 hydrogens. Butane. When you talk about butane, it has 4. Now, without wasting time, we know that the terminal atoms here will be hydrogens. Then the next one, pentane. It will have 5 carbon. Hexane. We call this parental chain names. When we're dealing with IUPAC, names will be using this. Hexane, it has 6 carbons. Then the next one is heptane, which has 7 carbons. Remember I said I'll be covering only the first 8, but along the lesson series we'll also be looking at the last 2. Octane, it means it has 8. We are dealing with hydrocarbons. It means that these molecules, they only consist of hydrogen and carbon only. What is very important is to know that we have methane as our first compound, which has 1 carbon. We have ethane, we have propane, we have butane, we have pentane, we have hexane, we have heptane, we have octane. So in this case, let us also look at another concept. You should know that the first part of the name actually tells you the number of carbons. Meth means 1 carbon. Eth means 2 carbons. Prop means 3 carbons. But means 4 carbons. One of the important things, pent, we know that from mathematics, pent simply means pentagons and polygons. Pentagon simply means 5. Then the hexagons is that 6-sided diagram means 6. Hept means 7. Oct, we know that from a grammar, octave, octopus simply means 8. So these are important things that you should know. And then within this name we have the properties. We can clearly see which this compound belongs to. I mean the homologous series this compound belongs to. Look at the last 3 letters, A and E. A and E simply comes from alkanes. Alkane. So the homologous series, you should know that their name will end with A and E. So it's methane, ethane, propane, octane, hexane. And you should also know that this is what we call them the saturated compounds. Saturated means they only consist of single bonds. You can see that the bonds between the carbons, it's single. Like this one, we only have sigma bonds. You can see the sigma bonds. We don't have any pi bonds. So this is one of the properties of alkanes. Another property that you should know is the functional group and the name. The structure you are covered, you can see these are the structures of alkanes, but you should know that they only consist of carbon hydrogen and carbon carbon single bonds. You will never find maybe a halogen here or any other element. We only have hydrogen carbon bonds and carbon carbon bonds. These are the properties of alkanes. Now let us get to this equation. If you know that, let's say you want to draw ethane, you know very well that eth, it simply means 2 carbons. This N is the number of carbons. So you can say C, where we see N, we put our 2, because you know that F, it comes from 2, simply means 2. And then H, we know that it will be 2 multiplied by this 2 that will be substituting here. We are going to get 4. Then this 4 plus 2, we are going to get 6. Then this is the molecular formula of ethane. Make sure you know how to use this equation, because during discussions I'll be asking questions based on this. We can go ahead and do another example. Suppose we don't know how many carbons and hydrogens we have in pentane. We are only given this name. but we know that pent simply means 5, so you're going to say CN H2N plus 2. Then we go ahead and substitute. C5 H2 multiplied by 2, we are going to get 2 multiplied by 5, we are going to get 10. 10 plus 2, we are going to get 12. And by the way, we didn't write the molecular formula, but we can go ahead. It's C5H12. We can do the same thing here. We know that it will be C6, then it will be 2 multiplied by 6 is 12 plus 2, you're going to get 14. Let us quickly do the very same thing. Here you can see that you're going to have C7H, then it will be 2 multiplied by 7 is 14, and then 14 plus 2, you're going to get 16. And then this, I leave it to you. So these are the most important things you should know about this homologous series, which is alkanes. We can go ahead and draw a condensed formula. Condensed formula for methane, the first one, it will simply be this one. Condensed formula, you have learned about it in the previous lesson video, whereby we've looked at different types of structures. So for this one, it will be CH3, CH3. Let us jump straight to the most complex one. So here we are going to have CH3, CH2, CH2, CH2 again, and CH3. Remember that alkanes, they are saturated because they don't have any multiple bonds between carbon and carbon. That's the bonds that we are checking between carbon and carbon. And remember that alkanes, they only have single bonds, and they consist of only carbon and hydrogen. We can say they are hydrocarbons. And remember that their names are derived from the name of the homologous series. You look at this: octane, ANE, heptane, ANE. In the next lesson video, we'll be looking at another homologous series, which is alkenes. So just make sure you continue with this lesson series and watch the next lesson video. That's it for this lesson video. This is Wahula SJ. Thank you very much.